Hello and welcome to this recording of a demonstration presentation that I gave to Cisco's Share IT Solutions Huddle on the 13th of January of this year, with the title of Building a Net DevOps Ecosystem Through APIs. Now, the reason I'm making this recording is simply ran out of time to really show the full potential of the demonstration. So I wanted to make a recording to fill in those gaps. My name is Daren Fulwell. I'm a network automation evangelist for IP Fabric. We're a network software vendor with a focus on intent-based networking and network automation. And I'm also co-founder of the Init6 initiative, basically a community around a bunch of CCIEs and expert engineers who are in the process of developing their skills to the new world of network automation and programmability and so on, and helping to take people with us. So we have a YouTube channel and various discussion groups and study groups that we're involved with, and this is part of that initiative. So network automation is the future. Hopefully that's a bit of a statement that we can all get behind. Especially in the last year or so, more than ever, we've seen what with only having remote access to the networks that we manage and we operate, and of course the release of the new DevNet certification program and all of the materials and information that's wrapped up around that. Thousands and thousands of network engineers are faced up to the fact that things have changed and have started learning programmability and development skills. But to put that in some context, does programming really equal network automation? Is the network automation in itself, does it bring the operational benefits that are often mooted? Yes, you're able to build networks at a greater scale. Yes, we're able to build them more quickly and ensure that the configuration is more consistent and so on when we're developing networks. Let's take a bit of a step back. Consider why it is that our employers and the organizations that we all work for have networks. They're there, clearly, to provide the foundation for all of our IT. Without us, we wouldn't be able to get our users access to the applications. We're providing the transport to make sure that we can get up-to-date data from our sensors and our data sources, whether they're in our organizations or wherever, to the places they need to be stored, whether that's on on-premises data center or whether it's a cloud service. The role is really to maximize service availability. How do we go about that? We have to build a network operations organization. We have to be able to monitor. We have to be able to maintain and support the networks that we build and the processes that have to be wrapped around those systems in order to make the networks work. And so we build up this ecosystem of monitoring systems, of log collection, of event correlation, of event management SIEM platforms. We might have an ITSM where process is controlled for change and incident and problem management. We'll certainly have a configuration management database, CMDB, for the organization. And that will be used by people way beyond IT functions, so procurement, contracts, circuit rental and those sorts of things. That information is key for those. So it's really, really important to make sure that that ecosystem is consistent. For example, we need to be clear that we're monitoring all our network devices so that if an issue occurs with them, we can track incidents against them. And of course, we need to make sure that support contracts are in place for them should something break in the middle of the night and we're not able to get hold of anyone to help us. Consistent inventory is the key. And of course, automation platforms being used to develop the system and make changes and so on should also be consistent to ensure that everybody has that same view. The key is to understand where the overlaps of data are and to make sure we have mechanisms to synchronize that data between the different tools. So how do we go about that synchronization or integrating those tool sets? Well, the key is to understand that data, where it's available, what's required in each of the different platforms, and how to ship it between. And typically that means APIs. Okay, that means understanding how we get data out of those platforms programmatically. So APIs are typically defined and documented to provide those structured methods of extracting and updating the data in those systems. We build scripts to map incoming data from one platform in one format to outgoing data for another platform. And then data can be synchronized and those gaps closed. We can also use webhooks and those kinds of mechanisms as triggers to ensure that updates happen in a timely fashion as a result of some other event occurring. Now, no one should expect you as a network engineer to build and manage and maintain that complex operational software to do this, but appreciation of the power of APIs and these mechanisms stands you in good stead at the cutting edge of net DevOps. At the end of this session, I'd like nothing more for you to go and sit down and start looking at how the data you have in your tooling can be enriched and synchronized using live data from the network and from your other platforms, and then understanding how the mechanisms that you need to transfer those data and synchronize them might look. So over the next 20 or so minutes, what we're going to do is we're going to step through an example of exactly this process. We're going to whiteboard out what it is we're trying to achieve, what the tool sets are, where the data is, and how we get it from one place to another. We're then going to do a quick code review. We're going to step through some sort of structured pseudocode first, and then we'll have a look at some of the more detailed code as to how these things are achieved using Python scripts. And then I'll run through the demo, which is a simple walkthrough of an example process. Once all that's done, we'll have a look at the takeaways. Apologies for the image. Okay, so we have a bit of a demo network in front of us here. We've got a WAN infrastructure connecting to a couple of sites. In our case here, we've got 2 routers, we've got some switches, both layer 3 and layer 2 switches. We've got in site 1 here, we have a wireless LAN controller, and we have a couple of wireless APs. And over in site 2 here, which is something more of a data akin to a data center, we've got load balancer, we've got firewalls, and so on. So we've got a bit of a mixed infrastructure. We've got a lot of different elements of network going on there. Now, in order to maintain those service levels, we need to make sure that we've got the right tooling available in order to give us the visibility we need for this. So in my demo infrastructure, I have a monitoring platform. In my case, that's Prtg. We have an ITSM system for our change process. In my case, that's ServiceNow. And I've also got a ChatOps environment built around Cisco's Webex Teams. I think it's just called Webex these days. And my automation, for my automation, I'm using Python and Nornir in order to develop my infrastructure. And so in order to make sure that all of these are getting the right information that we need, and that there are no gaps in the setup, we need to look at what these things actually require. So from a monitoring perspective, Prtg is going to need an accurate inventory, and we need to be sure that everything is configured properly. So it's configuration information as well required there for things like community strings and SNMP. ServiceNow is also going to need inventory, and make sure that that's all up to speed. And something we can do with ServiceNow is we can create and populate incident information into the platform, which is very cool. Now, as far as Webex is concerned, in this case, we're just going to use that for notifications. But obviously, there's nothing stopping you building chatbots and the such like, so that you're able to retrieve information from systems. And in Python, Nornir needs an inventory, same as everything else. So we want to be sure that that inventory is the same inventory that we can get from our ITSM and from our monitoring platform. Now, what we could do at this stage, we could build some clever, fancy scripts which go ahead and extract information from the network, and then make those act as a reference source, basically, for all of these systems. Now, I don't need to do that because I'm lucky. I have a platform that allows me to do all that, or does all that for me, without me having to maintain the ecosystem myself. So I don't need to go ahead and build the open source tooling. I don't need to put anything together. I've got a system that in here called IP Fabric, which, amongst other things, has a comprehensive multi-vendor network discovery. It pulls inventory information, configuration information, and puts things into vendor neutral database, so that we're able to query all of that information through a single set of API requests, simplifying and abstracting really all of the complexity of this network from into one place. So IP Fabric is my interface to the network, if you like, and that's what I'm going to be using for this demonstration. Now, so the bit that's missing is obviously the bit in the middle that gets the API data from IP Fabric and translates it and moves it through into the other platforms. And the way the demo is going to work for this, and I'll draw this out for you, is that we're going to bring up pretend we're bringing up a new site. That new site will have routers and switches, same as before, and some other stuff. I'll just draw one in here just as an example. And we'll call it, that particular one will be site 45. Just happens. Now, what IP Fabric will do, it runs discoveries and builds what it calls a snapshot of all of the inventory and all of the network at a point in time. So what IP Fabric will do is it'll create a new snapshot with this new site, do this discovery activity, and then when that activity is completed, it'll send out a webhook. Now, as I said before, all that is a very simple HTTP request triggered by an event that's happened within the platform. And what we're going to do with that, we're going to intercept that webhook in our own script. So we're going to take that as a trigger to then kick off some more activity. And what we're going to do here is we're going to get the inventory data. and we're going to get some configuration information from IP Fabric through its APIs. And then once we have that, we're going to look at how we then take that information and feed these other platforms over their APIs. Now, the one exception to this is Python and Nornir. What we're going to do here is, instead of storing a static inventory created from the IP Fabric data, we've actually got built a plugin that allows us to go direct to the IP Fabric inventory and pull that data back directly. So once you pull all this together, you can see that we're able to have that synchronized inventory from the data that's in the IP Fabric system. Okay. So let's take a look at the code and how we're going to approach that, shall we? Now, I use Virtual Studio Code, as you can see, in order to do my development work. I call it development work very loosely. I am a network engineer after all. But the approach that I take to doing this is pretty straightforward and comes really from my my old study days of university, when I used to do a bit of programming. What I do is I build kind of an overview of how I want this code to function in something called pseudocode. It's really takes the structure of the approach, but uses English language in order to describe it. And then what I do is iteratively step through that, change it into and replace the English with syntax that for the programming language in question, and then the English language becomes the comments in the to document the programming code. Let's just step through very quickly and show how that works. So in this case, I'm describing at the very top here what frameworks I'm going to use and the approach I'm going to take. Now, the first up is I talk about using Flask. Now, Flask is a framework for Python, which allows us to build web applications. So what I'm going to use the Flask framework for, very simple, is to create a web server to take input from the webhook triggers that we talked about before. Once those webhooks arrive, I'm going to put them onto a queue. I'm going to extract the data from them and put them into a queue for processing. And then once they're into that queue, I'm going to use multi-threading to take a thread to just service that queue. So it's going to, when things appear on the queue, doesn't matter when, asynchronously it'll take the data off the queue and handle it in whatever way it needs to. So the way that Flask will operate for us, we can break up the code into create functions really to return data based on the URL that's being accessed. So in our case, very simple. If we ask for the index, then we'll just return something random. If we've got a post to the webhook URL, then what we're going to do is we're going to take the content of that message out and we're going to put it onto the queue. Very simple. The real meat of the thing is in the queue servicing process, and that's this description here. This is how we're going to do this. Now, IP Fabric, when it puts these sends out these webhooks, it puts in both a type and a status for the event that's caused it to happen. The ones we're looking for are the completion of a snapshot. So this is once a discovery has been completed, I've got the new data, everything's ready to go. So what I'm going to do here is really, in effect, if it's not a completed snapshot event, I'm just really going to log it and ignore it. I know it's happened, but I'm not going to do anything with it because I'm not wanting to for this purposes of this script. But once I've got the snapshot completed, what I want to do then is go ahead and fetch information about the snapshots that are available and diff the inventories for the added devices. So I want to find out which devices were in the newest snapshot that weren't in the previous one. Once I've got that, I can check on their SNMP configuration. If the devices aren't configured for SNMP, what I'm going to do is add them to a list, but I'm going to create them in Prtg anyway and just pause them. If they are configured for SNMP, I'm going to go through the community string details and select a best match. So this is one that I feel with my logic is the best match. In this case, what I'm really looking for is a read-only community with an ACL attached to it. I've got other options as I go through here. Once I've found that, I can then add that to the configured devices list, and I'll create that in Prtg with that best community string, and I'll commence what Prtg calls its discovery, which is essentially allowing it to go ahead and start querying that device and start pulling in information about its interfaces and so on. I'm then going to go to ServiceNow, and what I'm going to do with ServiceNow is look up the location and vendor references. ServiceNow has a complex relational database that sits underneath it. Things like location, things like vendor tables that are very specifically tied to other processes within ServiceNow, and so they need to be strictly controlled. In order for us to be consistent, we need to use the appropriate references in our tables, in our inventory tables, so that we're sure that their associations are correct between our new inventory and the locations and the vendors that are associated perhaps with support contracts and so on. So we're going to do some lookups there to go ahead and pull that information through, and then we'll add our device into the ServiceNow inventory. Once all of those devices are done, we've then got an unconfigured devices list and a configured devices list. If there are configured devices, then what we'll do is we'll create an informational ServiceNow incident with that list in it, and make sure that people know that those things have been added, but it's just an informational incident. There's nothing to be done with it, and we'll drop a message into the Webex Teams room also with that ServiceNow incident reference. If there are any additional devices that have been added to Prtg but not configured yet, this is the one that needs some action, because what we need to be sure we do at this stage is somebody goes ahead and makes the changes to those devices so that they can be monitored, because otherwise you've got devices connected to the live network that aren't being monitored. So we'll create an action incident with a level of urgency. We'll put those details of the devices in there, and then only when they're done will they be resumed in Prtg. And again, we'll send a message into the Webex Teams room with that incident reference. So that's our pseudocode and the structure for our code. I'll show you briefly what the actual code looks like. I'm not going to dig into it in gory detail, simply because time pressures as they are. But you can see here the Python scripting where we're pulling in, we're importing a range of modules that we're using to do the activity. And you can see here's Flask, we've got the threading in here, we've got queues, we've got I'm using the requests module for building API calls. I could use HTTPX for that, which is compatible. And I'm also using the Webex Teams SDK here. So for 3 of the platforms that we're making API calls to, I'm just using simple request building. For Webex Teams, we have an SDK that we can use. This one is an open source one. It's been pulled from GitHub, which means that we don't have to go about manually building the API requests. We'll come to that shortly. Whole load of global variables here with usernames, passwords, API keys. Obviously, in a production environment, you would not do this way, but this was purely for this demonstration purpose. And then we roll through into the actual code itself. Here's our definition of our index, in which case we're just returning some random nonsense. Here's our definition for the webhook URL. Now this, you can see, all we're doing is we're putting the request JSON into the pipeline, onto the queue. And then we have our consumer process, which is the thread that runs and pulls information out if the snapshot is completed. And you can see here, as we step through this, there's our if message status is completed. And then this is the process by which we go ahead and carry out those tasks. Now, what I'm going to do here very quickly, I'm going to show you what the API requests look like, and the reason for that is because, well, they're all different. So it'd be interesting just to see very quickly what approach we've had to take to do these. So I'm going to pick this one to start. This is the snapshot information that we're pulling from IP Fabric. Now, to assemble request into IP Fabric, we get we assemble the API endpoint, which is nice and simple. It's using an IPF server and IPF base URL variables from up here, and then we build the request using IPF headers to that URL. Very, very simple. Now, IPF headers, as you can see here, uses an API token. That API token is from the system. Once you've logged into it, it's associated with the particular user, and it's a long-lived token that you can just use for this purpose, which allows us to do our authentication very quickly as part of the request, and instantly we've got our response from from what's returned from that request, and we can process it. If we're wanting to pass any parameters into IP Fabric, what we do is we create a request body typically, and that will look like it's a piece of JSON, as you can see here, that we've assembled, and then we just pass that into the request here as a body of the request. And in this case, what we're doing is we're pulling out a specific set of columns from the tables, and we're filtering it based on devices that have been added between the two snapshots, for example. Okay, so nice and straightforward. Okay, so we continue. We pull more information from IP Fabric about the SNMP and the community strings. We go through and we do our checks to make sure that we've got information about how things are configured, and then we come to Prtg. Now, with Prtg, in order to create new devices, we duplicate existing ones, because that's how the API works, and because it's very complicated doing it any other way. So as you can see here, we assemble our endpoint, duplicate object.htm. Now, the parameters for this endpoint are done slightly differently. As you can see, what we're doing is we're building a string here containing, amongst other things, the username and the password, the device IP address, the host name, and so on. And we're encoding all of the parameters into the URL. And then we post those directly with a question mark in between the endpoint and the parameters, with the body of the request empty and the headers empty, in order to process that. So everything, right down to the username and password, is URL encoded. So that's the second different way of accessing an API. We'll do some extra stuff here. We'll tag some, we'll set some tags, we'll configure the SNMP community strings, and we'll resume the devices where necessary. And then we roll down into the next phase, which is looking at, again, we go back to IP Fabric for some vendor and site name information for the devices. And then we roll through into ServiceNow. So this is the next request. Here's our ServiceNow endpoint, again, assembled in much the same way. Here's our request to ServiceNow. Now, you'll see here that what we're doing is we're going to the API endpoint, which is specifically to pull information about the core company table. And all we need to do here is authenticate against it. In this case, we're going to use standard basic authentication. We insert into the request the the authentication tuple of username and password. What the request routine will then do is go ahead and assemble that as a base64 encoded string and pass that to the endpoint, the API endpoint, in order to authenticate against that username and password. The request comes back, we take the text information from it, and away we go. We do the same for the locations, and then when we come to create the new inventory items, we do the same, except that we need to pass some data into the platform. And so what we then do is we build out, using JSON, we build out a dictionary that represents that device and with the appropriate fields. We post that into ServiceNow, again using the basic authentication method, but this time using the device data information that we're pushing into the platform. So that's ServiceNow. So that's number 3. Again, different again. We roll through now and we have Webex Teams. Now Webex Teams, as I said, we're using an SDK. So what we do here, we create an instance of the Webex Teams API class, and we interact with that instance, and that's what actually makes our calls for us, using someone else's code rather than us having to assemble it ourselves. Okay, so in this case, and I'm going to just scroll through this, because what we're doing is we're building incident data in order to push it into ServiceNow, and then we're reusing that data in Webex Teams. So as I roll through to here, you can see we're going through that process of building the data, getting the endpoint, and doing the request. That's for ServiceNow. And then we just reuse that in this single line here, Webex Teams room.messages.create function, using the same data that we've talked about here. We've already specified the room, we've already created all that information, and essentially all we're doing is we're just running this function, and that function goes ahead and does everything for us. Now the authentication here is done using an API token similar to IP Fabric, but in this case it's pushed in using an environment variable rather than a variable within the code. So there you go. So that's 4 different APIs and 4 different methods of actually accessing them. And then we roll through this. There's lots of logging, as you can see here, and I've used the rich rich module in order to just color that so we can see it as we go. And that's essentially the end of the routine there. And this section at the bottom here is just essentially starts the threading, the multi-threading process. So complex code, but bear in mind, as I said, I'm a network engineer. I wrote this myself. Once you've done it once, it really boils down to how you get information out of some APIs, how you then work with that in order to push information into others. And really, it's a data science piece of work. Anyway, I've bored you stupid with the code. Let's take a look at the demo. Okay, first things first, let me just explain what we've got in front of us here. On the left hand side, this is IP Fabric, which is, as you can see, has device data and various other pieces in here, and a load of snapshots from the network that is already existing. On the right hand side, what we have is a console into a Linux box, which is running or will be running the scripts that we're going to be demonstrating. It's also obviously got access to Nornir, which is handy because we want to show the Nornir plugin and the fact that it's pulling inventory from IP Fabric. So let me just give you a view of that. So I've already installed Nornir and I've installed the plugin, and you can see here this is just a standard way of initializing the Nornir inventory. The difference being that I'm using, as it says here, the IP Fabric inventory plugin, written by a good friend of ours, Gianpaolo Barina, who is both a customer and a partner of IP Fabric, but also a upstanding member of the community, who has considered writing this for us. So it's really useful that we've got a lot of people working with us on building these sorts of integrations. Now, if I do an inventory update, you can see there that I've pulled inventory information through from these snapshots here. I can just very quickly show you the list of devices. These devices are these devices basically, so we can just prove that out. If I pick, let's pick that one, L47 ACC19. There it is, and you can see it's a showing up as a Linux L2. There it is. Its IP address and serial, there it is, 1047.119.150. Yeah, and it's managed over Telnet. There we go, perfect. So we've got the information we can see marries up with the information that's already in IP Fabric from our existing snapshot. Now, our team are going ahead and making live Site 45 tonight, as we said back at the beginning. Let's see if I've got any inventory for Site 45. So what I've done there is I've just filtered the inventory for Site 45. And let's have a look at that. No, you can see there I've got no hosts and no information at all there about Site 45. Okay, that's fine. Good. So showing that the inventory is synchronized. So that's all good. Now what I'm going to do is just roll through and start off the webhook handler. And there we go. You can see there it started the webhook handler. You can see the Flask out there, and you can see that I'm serving out on port 5000. If I come through to IP Fabric, I'll just show you very quickly the webhooks configuration. You can see there is going through onto port 5000. So this will, as events occur here, they should trigger this in the events to happen on this script. Let's see, shall we? So I've already gone ahead and done the discovery. Normally at this stage, of course, you would actually run a normal discovery. In fact, IP Fabric would normally every evening or twice a day sometimes it would discover all your network for you automatically. Now we've already done that, so I don't need to go through that process. It would have taken a little bit longer, as you, I don't know if you saw before, about 12 or so minutes. We've not got 12 or so minutes to use, so I've got by loading the snapshot should give me a couple of minutes instead. See how we get on. You can start to see devices appearing here, and these will slowly fill out. Now these I'll let that crack on. While that's doing that, I'll show you very briefly the other tabs we've got open here. So this is Prtg, and Prtg at the moment has no devices under its network infrastructure other than the template device. We mentioned before that when we create new devices, we need to duplicate objects. This is the object we're going to be duplicating, our template device. So we'll see how that progresses. That's our next one. Okay, so this is our ServiceNow window. Now we've ServiceNow's just session's expired, so I'm going to log into that session. There we go. You can see we have an inventory here, but we have just some test devices in the inventory, just 5 test devices. So nothing much happening there. And we've got a couple of test incidents raised in here as well. We've printed the office out, a toner, and issue with email. So let's see how our script works with these. So let's just go back and have another quick look here. Right, so this is still 50% loaded. We've got a minute and a half down, so we've got a minute or so. So IP Fabric has already gone through the process of logging into all of the devices, of pulling back configuration and state information. And what it's now doing is assembling that data in a vendor neutral tables in order to make sure that it understands not just how devices are connected, but how they're interacting, what routing protocol relationships there are, what MAC addresses look like, what the routing tables look like, and so on. So we're pulling a whole raft of data through. And all of that data is accessible through the API. Of course, we're just using a relatively limited set of that. But we could, in theory, if we wanted to, we could pull topology information out and all sorts of cool stuff. As it is, we're just going to pull out inventory information and SNMP config. You can see there it's just building the network topology together now, so we should be clear shortly. There we go. Right, so you can see now as this is completing, and on the right hand side we've seen the webhook has landed and we're off and we're busy doing things. Okay, so IPF snapshot completed. There's that snapshot completed event. What we do then is we find the information about the 2 snapshots, the last one and the previous last one, and we fetch the differences. In this case, 13 differences between them. And then what IP Fabric's doing is looping through all of those, checking to see if they're configured. If they are configured, getting the information. If they're not, updating and pausing devices in Prtg. And you can see all of the triggers down the side here as to which APIs are being called at which times. If it's red, there's something awry, and an amber is just just a warning. Okay, but green is generally good. And then you can see right down the bottom here we've got a snapshot complete, and all the actions associated have been completed. Now let's check on that, shall we? Well, here we are over in Webex Teams, and you can see here we've had 2 messages land from Webex Teams. One is saying that there's been some devices added to Prtg, auto discovered, and they're currently monitoring. So it's just an informational one. And then this second one is saying a second incident's been raised, and this these devices have been added to PRGs but were paused and awaiting device config. So if I click through on this URL, hopefully that should open up my ServiceNow instance, and there's the incident as promised, 1.064. There's the description. If I scroll down, here's the list of devices and the IP addresses that need to be looked at, and you can see the impact and the urgency are high, and it's a critical priority because you've got devices connected to the network that aren't in monitoring according to this. Okay, so if we go and look at the incidents in ServiceNow, the 2 incidents should be showing in the list here, 63 and 64, all good. Going left one into the network here, so this is the inventory for ServiceNow. What we should have is a list of all the new devices. So these are all of the devices that it's discovered that weren't previously discovered, and you can see here we've got, if I click through on one of them, we've got real information in the vendor, it's actual Cisco, and we've got real information in against the location here, L45, and that's because it's gone through and looked up in the existing tables and inserted the correct references here. All good. And then if we roll through into Prtg, and here we can see we've got a whole load of green stuff here, which is all good, always good to see, but we've got our new devices, L45, R6, R9, and so on. These are all the devices that have been added into the system. Any that are blue have been paused by the users. So these are the ones that are currently awaiting configuration. Now, if I just click through on one of these, just as an example, and look at the settings, you can see that I've got the IP addresses that have been pulled through. I've also added a tag here to show which snapshot that those have been found in and added to the system as a result. And nothing more to see here. Yeah, that's good. And you can see that auto discovery is going on as we speak. And so there we have it. I mean, the next action from this would be to go ahead and make the changes to those devices. Now, we could, of course, use automation to do that. And that's unfortunately a step too far for this demonstration, but we can just go back into Python and just have a look at that Nornir inventory, just to prove that we are actually looking consistently at the right inventory. I'll just make sure the inventory plugin is fetching some information. Yes, it is. Let's have a look and see if we've got some devices in Site 45. Yes, we have. There we go. So looks promising, doesn't it? So there you have. You can see that the automation platform, the ITSM, and the monitoring platform are all now synchronized in terms of their inventory, all using the same information. And we've got a mechanism there that will actually update that whenever we find new devices. So let's consider our takeaways. The first thing to think about really is that when we're talking about toolset integration, what we're talking about is translation of data, taking the data in from one system, changing it into a form that works for another system, and then using APIs in order to first extract that data and then to push it to where it needs to go to. One thing I will say at this point is really useful to bear these things in mind when you're choosing your network tooling. The better and more complete that an API is, the easier you're going to find this to integrate with other platforms. if you've got tooling that can translate complex information into simple APIs, you're going to save time and energy and not have to build and maintain the tool chain. No two APIs are the same. If you think about the 4 that we used in this demo, all of them had different combinations of authentication and parameter delivery. Even within a vendor's product range, this is true. If you've done and studied for the DevNet Associate exam, you'll find that all of the Cisco APIs that are listed there, I think I can't even think of 2 that are exactly the same in terms of that delivery, simply because of the way these tools have been developed and the approaches that have been taken. Watch out for that. You need to understand what those differences are and how those are approached. But once you've got it, it should be relatively straightforward for you to reuse code. But you could always look for SDKs to make life easier, so you don't have to go about assembling those requests yourself. If someone's already gone through that process and created the classes and the functions, and why go ahead and do it yourself again? And by all means, there may be more than one, depending on what tooling you're using, and some may be open source. So you may find official ones for the vendors, and you may find some that people have developed for themselves. So definitely worth going ahead and really researching them fully. I guess this is the key, right? When you can see past, and I'll call it simple automation of the network element. So network automation in itself is great because it's giving you all of this capability of being able to push, manage config and make sure it's consistent and all of that good stuff. But we're going further here. If you can stretch out and understand how synchronizing and filling the gaps between all of those other elements of your operational ecosystem, you're really increasing your value to your existing and potential future employers and making yours and your team's lives easier and less stressful. I've got a few references here worth having a read. The slides will be available, so please, and I'll make sure that you've got the notes from these are held as well. I will mention the last one on here, IP Fabric. If you are interested in IP Fabric at all, having seen what you've seen today, please get in touch with me. My email is daren.fulwell@ipfabric.io, and you can get me on Twitter at Daren Fulwell. I will say no more than that, but you can see hopefully from that tooling selection I mentioned before how something like IP Fabric is a massive advantage in building out this ecosystem. Thank you very much for your time. Thank you if you've made it this far watching the video. I hope that it's been of use. Thank you.